Hello, this is Paul from Foresight Tech. In this video, we are going to deal with the differential, which is a concept related to linear approximation. We learned from the last topic. Let's see the material. First, I will introduce the definition of the differential. Then we will practice just one question together about how to find the differential using just the definition. Okay, we can see here is the definition. And we have two differentials. Okay, so the first differential is called the differential of x. Can you see the definition? dx is the differential, defined by the increment of x, delta x. Okay, increment, which means the change in x, we defined it as the differential for x. The second is the differential for y. Okay, and the definition is the derivative times dx. We already have the dx, right? Therefore, we have the differential for y. And this is the definition. Okay, and Leibniz is the person who proposed the differential at the first time. Okay, it looks very strange for us. However, if I change the second equation into another one, you will find is very familiar with us. Okay, so we look at this, and on the right side, if both sides, if I divided by dx, okay, if we divided by dx both sides of the second equation, what do we get? We will get this. We will get the dy over dx equals the prime derivative at x. Okay, so this should be very familiar, right? And the left is the Leibniz notation, right is the prime notation. Of course, both tell us is the derivative, okay, the function at x, which means consistent. And if we define the differential now, we have another understand for what is this notation, okay, Leibniz notation. So at the very beginning, dy dx is a whole, okay, which means the derivative. But now we see this is still derivative, but we can see the derivative as a ratio of two differentials, right? Okay, and we define, and the calculation is not difficult. We just follow this definition. But what does it mean for dx and dy? Okay, and the dx we know is the increment of x. So what is dy? Let me going to look at this graph. Okay, and suppose we have a function, okay, and the function is differentiable at x, which means at this point p. And therefore, if we draw a tangent line, you remember the last topic, linear approximation. Okay, the tangent line should be approximated to the original curve around the p, right? And then if we give x increment delta x, okay, so we have this point, draw vertical line, we have a right triangle. If you look at the point p to the point r, and the right is here, and the run, definitely the run is a differential dx, no problem. Now we're going to find out y. The rise is just the differential of y. Okay, all we need to do is just look at this equation. Okay, and if we put the dy to here, dy is the rise over dx, the run. What do we get? We get the derivative, right? We get the slope. The slope is just a derivative, therefore it's consistent. Okay, easy to see. So where is dy? Now we see dy is just here. This is not the final meaning. The final meaning is linear approximation. We can do another result. Can you see the remark? Okay, and we can change the linear approximation into this statement, which means delta y can be approximated by the differential. Okay, this is the final meaning for what is the differential mean. Differential means approximation to the increment of y, or to the difference, or to the rise of y. Okay, and y. So let's look at this graph again. Okay, And because delta x is small enough, therefore the line, the tangent line is close, right? Is approximated to the curve. Okay, and therefore the point, can we see the point R should be close to the point Q. What does it mean? This means dy should be close to delta y, right? Therefore, is this meaning. Okay, they tell us the differential is just approach to the increment of y. Okay, this result is just the meaning of the differential, and we get this result from the graph, and we also can get the results from just the algebra. Okay, so we can change the linear approximation to this statement. Let me go to see about here. First, I will write the linear approximation. What is a linear approximation? Is just like this. Let me put what is a linear approximation. Okay, we defined the last topic, which is this. Okay, I put f x approximated by f a plus f prime a times x minus a. Remember this, right? Okay, this is the formula. However, on our graph, so I will change it a little bit. We're going to approximate is the value of the function at x plus delta x. Therefore, I will change this x to x plus delta x. Then what is a? The point a is at p, which is x. Okay, so I will change this a to x. Okay, so now we were going to change this formula into another one. And now what is the formula going to be? Is this f at x plus delta x is the left, right? Approximated by f at x plus. Okay, and the f prime a is x, right? So we put x. What is x minus a? X is this. X plus delta x minus x, which we get delta x, right? So I put delta x here times delta x. Now this is an equation, so we subtract the fx both sides. Can we see? And we will get this. And this is y. Okay, minus fx can be approximated by f prime at x. Remember the definition. Delta x is just a dx, right? So we put the dx here. Okay, so the left side is what? Is the increment of y, right? The increment of y, which is delta y. So easy to see the left is just delta y. What is the right? The right is the definition for what is the differential, right? We just have this is a dy. Can you see? And if we through these a few steps, okay, from algebra, we definitely will get the same results. And that's all for the meaning. Okay, what is dy mean? Dy means approximation to delta y. Now let's going to work on one question, okay, to find that what is the differential dy. Here is the question. And we have two steps. The first, find the differential dy. The second, evaluate the dy at x, at the given x and dx. Okay, all we need is follow the definition, right? Let me go into the first. The definition, what is dy? Dy is y take derivative, the derivative times dx. So we need to find the derivative first. Okay, so find the derivative is not difficult. Let me see a. We need to find the derivative first. So what is dy? Y prime is the derivative, right? So look at this function. Okay, this is a composite function. Is this a composite function? Of course, we're going to use chain rule, right? So we have to use a chain rule to find the derivative. Okay, so is this the derivative of the order, which is a cosine at u. Take a derivative is a negative sine at u. U is a pi x. No problem, right? and then times the derivative of the inner. The inner, of course, is pi. So we times just the pi. I can change it a little bit, the order. Can you see we get a negative pi times sine at pi x. So we find that the derivative, right? Now we use the definition to find the differential. What is differential? So dy equals, let me write the formula first, is the derivative. Okay, you can use this, no problem, and then dx. Okay, we find already what is the derivative. So plug into the prime of y, which is this. Get a negative pi times sine pi x. This is the prime, and the times dx. See, this is what we get the formula for the differential of dy. Now the second is evaluate. Of course, evaluate just plug in what we need. So we say we need to do this. We need to evaluate dy at what? See, at the x equals 1/3 and the dx equals another. Which is this. Let me write it here. Is x equals 1/3 and the dx equals negative 0.02. Okay, so now evaluate. We know dy. See, in this formula, x is 1/3, dx is negative 0.2. So plug this into the formula, right? See, what we get is a negative pi times sine. Okay, pi times 1/3 is pi third over 3 times dx is negative 0.02. And this is easy to do calculation, right? And sine at 60 degree is square root of 3 over 2. And this 0.02 is 1 out of 50, of course, negative. And then times together, see what we get. And then we get these results. Negative, negative goes to positive. So we have a square root of 3 over 100, right? Times pi. We still have a pi. Okay, so this is the answer for this question. We already. You remember what that the meaning for dy. So this is an approximation to the other y. Okay, when the increment of x increases this a little bit, and what is the change in y? Okay, we can do this approximation. That's the meaning. And that's all for this topic. And if you have questions about this topic, please leave your comment. If you like this video, please give me a thumbs up. And you are very welcome to subscribe to my channel for more videos. Thank you for your support. In the next video, let's see. So we are going to deal with the hyperbolic functions, which are a new set of functions, but with many connections to trig functions we learned before. I hope to see you there. Thank you. Have a nice day. Bye.